again back to you on this day, March 7, 2021, Sunday, of course. And my last video was having audio problem, and for 10 more than 10 minutes I think I wasted time. No problem, some written was there, you could read that statement. And I had talk on quality. Good morning again. I think there's some problem in relay this day, March 7th, 2021. First it gives minutes and then it gives seconds, or some technical issue. I was wondering how it's happening. Again it happened this time too. So we have to manually complain, of course. When talking of quality system, I was somewhere on Fairface structural works. I just started that and there was some problem. After some problem, I can't help it, no problem. But let us move further. Problem shall remain. Life is problem. I explained a lot about quality, but I just started application of quality on Fairface, and this appeared unexpectedly. Fairface, which I am interested to explain. You have read it, of course. It was for a couple of minutes there. You might have read Fairface doesn't require any plastering on former surface. That is true. There is no need of any cover up on that Fairface because name itself is Fairface, which your face is clear. Your face is no undulations, your face is no marks. It is completely free from an unacceptable mark. Its profile is clear, it's planar, and it's completely vertical in plumb and right in dimensions, and is completely honeycombing free. It's completely cracks free. It's acceptable surface, and its exposure, its projection will be visible forever, except application of decoration on that, or you may say paint on that if required, or it's natural. Means that is Fairface where you have to apply nothing on this for cover up. It's natural RCC surface that you will wave it. There could be little, there's no grinding allowed even on this, or very fine grinding could be there on some defects which may not be visible, but no honeycomb, no cracks, no, you can say, other defect that could be accepted in engineering application can be seen on Fairface, particularly on external elevation applications. Usually it is done. I worked on a building in Baghdad in 81, 82, I think 82, and there were elevations in Fairface. All elevation faciae of Fairface, and it was a problem for us to actually do that because of habits of people not to be too serious about Fairface. Everybody thinks that, of course, after this plaster shall be done, and if there's some defect, we can cover up in that plaster. So it is this concept. No plaster is meant for covering your defects. This is not acceptable at all. There is no such acceptance anywhere that we can cover up defects in plaster. No, you cannot do that. But people think so. Some people do this, you know. Some people do this havoc. You can say this is engineering slaughter. I can say to think even to cover your defects in plaster or rendering is killing engineering, is to cheat yourself. Purpose of plastering or rendering doesn't mean you cover up defects. That is protective membrane, plaster or render, cement mortar, lime mortar. That is only to protect surface, not to cover up defects. Surface still is same, means at least to prohibit some moisture enter directly into body of concrete. Some chemicals, some chlorides, some other foreign materials to impact on solid surface of concrete, it is only for that. Means just to protect it from the air, to protect it from direct sunlight. Sunlight impacts first interfaces, intercepts first plaster, and little impact goes to surface of concrete. That is sole purpose, means it's a kind of flexible cover that protects surface of concrete to some extent. It's nothing else, means you cannot say that you want to hide defects. That's why plaster is done. So fair face is actually structural real concrete, one should say. Every surface of concrete should be fair face to my understanding. Plaster or cover up has no answer to that. If you are doing quality concrete, quality work, work should be fair, work should be acceptable. And if you want to do on that application of plaster, this means you have to first chip out, you have to hack surface first for purpose of bonding. So indirectly speaking, you are going to destroy to some extent surface of concrete, means cover of concrete. Cover of concrete which could be 30 mm in case of column, which can be also 40 mm in case of column, or 30 mm in case of beam, which you are going to plaster. You never plaster foundations, you never plaster step columns, you plaster only superstructural members. Soil, they are immersed in soil forever. So because of backfill surrounding soil. But that doesn't happen in case of superstructure. So people say, okay, we just try to protect this member. But every member should be fair face. And if you do bonding on that with plaster, you have to provide some means, and that's hacking. And I don't believe that if your really concrete is fair face, there are so many paints you can apply on them for that purpose, for protection. Actually, I should say on concrete surface, application of plaster is self-satisfaction only and not real requirement. Because cover is there and we have to provide porous, non-porous concrete. Concrete should be as little porous as is possible. There should be very little chance of chlorides to penetrate, or water to penetrate, or air to penetrate. Means it should be perfect concrete to practical percentage application. Fair face, every that should be as much fair face as possible. Means we have to change our basic thinking about conventional practices are okay, that's fine. But is that right? Fair face, just I say my face should be fair. But if I make up or if I apply some facial and I say my face is fair, well, that's a deception, self-deception. Or if you wear makeup, some female wears makeup and she looks very attractive, it doesn't mean that's fact. That's a hide up, that's concealing facts. So engineering is actually an exposure to facts of life. If my bricks are not good, my blocks are not good, I want to hide those surface defects. Alright, plaster. This means those materials are not either manufactured to requirement or to mark, and we have just to accept them because there's no other option. So is structural works. He should be fair face in fact, but not to someone who would say, oh, you worked overseas in that country. Engineering is engineering. It's your mental setup that gives quality. It's your mental setup how you conduct an engineering. Fair face is question mark. Why specifically fair face? When face is there, shuttering is there, everything is there. You may use plywood or you may use your planks. Whatever you use, everything should be systematic. You cannot simply say whatever. I mean, say good compaction. You should have wonderful, you should have resistant structural formwork that can sustain forces coming from concrete, wet concrete, or you can say green concrete, or you can say fluid state concrete, which exerts pressure on vertical sides of member. That's requirement. But how far do we analyze that? Everybody is interested in doing same thing which was done before. Not to think on that. It doesn't mean whatever was done before had been acceptable. Okay, because of practice people accept that, but not engineers. Engineering means use your mind, and when you use your mind means you use your mind. The structure should also be accordingly done. If I can't use my mind, I can't put in any structure. If I use my mind, I'll think of that structure, means I have to see everything from every material, combine grading, this grading, that grading, what's the quality of cement, what quality of material, how it works, everything about what type of setting I'm using, what type of covers I'm using, and what type of steel I'm using. Every material I have to make sure this is doing. It doesn't mean it increases cost. No, it doesn't increase cost. That is also misconception. Your experience can tell you what you are doing. If I say I want dense concrete means there is a relative density of concrete and which is 2.4 to 2.5 tons per cubic meter. I should get that. And if I get that means I can say yes, this is dense concrete, and little chances of permeability in this concrete or porosity means as minimum chance as possible. Means we cannot say it's perfect, but it's comparatively better than. And if this concrete surface is so strong, so hard, and so dense, it doesn't allow flow of chemicals into this, flow of chlorides into this. Through this, even in cover, it doesn't permit flow of chlorides and sulfates, whatever adverse material available in climate, air. That's what's required. I have to think of means this fair face is so few that it doesn't allow structural distress in concrete. Low distress is also, but I'm saying distress due to external agencies, not part of concrete, means these agencies are not welcome by concrete. Those agencies should be kept off, barred, prohibited from entering into cover of concrete. That's what we think we should do. It should not only for specific concrete, I'm talking of should for all concrete surfaces which are meant for permanent use. Means even though you are going to plaster that surface, it doesn't mean that it is acceptable in defective form. No, not at all. You can't accept substandard material or below specifications. When you provide formwork, this means formwork. It's not simply cover up, it's formwork. It should be well done. Its surfaces, all surfaces should be clear, should be in one profile. should be in plumb, should be in dimensions, right dimensions, and no leakage from those surfaces through joints. And well balanced system means no allowance to opening of sides, means it's hard work in fact, but progress doesn't permit that. I want progress of this. Yes, you want progress, but what about progress of quality? You are interested in progress of quantity. What is interest of progress of quality? That's a big point. I have to answer to ourselves. I'm not going to answer someone else until I'm satisfied. I cannot claim that I'm satisfied. I cannot project that product to someone else if I'm not happy. So that's the point. Engineering is not, you cannot say object of engineering is to make money or to do quantity. Object of engineering is quantity and quality must be together. So fair face, it's fair means it is not objectionable. And if it's objectionable, then there's no meaning of fair. I want to keep concrete exposed. I should have that much caliber in my concrete. My concrete should be that much resistant to weathers, that much resistant to everything. And just the paint coat on this keeps it protected. If I can do that, I think it is success. Or no, I have seen people, I'll do plaster on that, don't worry. There's a 6 mm bulging, there's 100 so 10 mm bulging, don't worry. I can protect in plaster. And what they do, they just keep on 2 layers of plaster, 20 mm plaster or more, and after a couple of years you find that all peels off, the falls, and again surface is same. So plaster or render is no answer to defects. There should be first of all no defects, and if there are defects, then there is ways to repair them, and that's what a quality repair is. But fair face must be kept in view, even though it's not defined. You cannot say we will give you what we are paid. Yes, you are right, you will be, but we are paid for good work. You are not paid for honeycombing. You are not paid for cracks in concrete. You are not paid for, you can say, a rough surface of concrete. You are not paid for porous concrete. Means if you calculate it that way, you will find that you are doing substandard work. You do substandard work, and that substandard work is not an answer to anything. So that's why I included this item of fair face, because I experienced that. I still remember my time in 82 when I was in charge of a tower portion in Baghdad. I think the press name building was Press Dar Al Thawra. Dar Al Thawra in central location of Baghdad, adjacent to Qasr Mutamarat, which is called Press Conference Building. Conference Building. Conference Building, we used to call it Conference Palace, actually, not building, Conference Palace, and he used to call it Mutamarat. Well, on that building, on this particularly tower portion, I was working on that. All fascia, all external fascia, whatever elevations were there, were fair face defined. It was fair face, and there was no tolerance, a negligible tolerance. Dimensions should have been exactly, there should have been no defect in surface. Alignment should be 100% correct. And actually it was time consuming job, very, very time consuming job, but we had to do it. To be very frank, I learned a lot being very young engineer at that time. I was 26, I remember, 26 or 82, and I was born 55, so yes, 26 or 27. I learned a lot from very strict supervision of those Iraqi people. Very close supervision they should do. And it's not because they were engineers. One of them, I still remember, one old old person of Iraq, who used to come all time to check at least shutters, if not reinforcement. He was expert in checking shutters homework. And it was known that he had been a good carpenter in his lifetime, shutter carpenter, form carpenters. And resident engineer never came to check homework so closely. Even assistant resident engineer was a Bangladesh person, did not come. This person used to come. Actually, even if those resident engineers used to check, this person used to overcome them. And used to not only used to come before concrete was poured, used to come post concrete pour to make sure that it's okay according to drawing. Well, it was like, you can say, he had some objective to see good concrete, and he took time, a lot time, to ensure dimensions, ensure column spacings, ensure sizes of column, to ensure verticality within limits. You know, one millimeter in 1 meter, which is negligible, you can say. We used to cast, say, 4 meter column or 3.5 meter column one go. That was acceptable. There was no problem that time. You can cast 4 meter column, but it should be according to tolerance. Even though there is pressure when column is filled, 4 meter is filled with concrete, there's enough pressure. Your shutters should be so strengthened that these can resist that force, horizontal force. And we learned that we have to provide that strong column sections, column shutters, column supports, bolts, props, everything. And a lot of time was consumed in doing homework. It still was not that difficult. Shuttering took a lot of time. Though even in internal structural members which were to be plastered or stoned, I don't know what was that, but we are doing concrete on that. Forget external one which are face, internal one also, checked that way. To be very frank, I did not even imagine that such strong, at that time, consider that time, not today, consider 1982, when there was hardly calculators, nothing else. And you used to teach us, I want to check this way. And he actually demonstrated how did he want to check. And we accepted that, okay, we will do this way. When you come, we'll keep ready site, we call you for inspection. We'll keep site accordingly, means what he used to say, take out from axis of column 1 meter, 1.5 meter, whatever is possible. And then from that thread to that ply of shutter, how much it should be, or to batten of shutter, how much it should be. He used to work out that himself. Say 1 meter, if we take 1 meter minus half depth of this dimension, minus 18 mm ply size, minus battens, whatever is 50 mm or 75 mm, and then whatever else is there. What is balance? It should be that much. And that's right, calculation wise, it's okay. It should be that much. And that's only for purpose of alignment. And alignment not one, alignment for whole dimension. And of course, when alignment is one, other side also alignment you will see. So once you prove that your dimensions are okay, your alignment is okay, then it comes to make sure that your plumb is okay. And really plumb was very, very strict. 1 in 1000 mm. 1 in 1000 mm, because 1 meter is 1000 mm. 1 millimeter in 1000 mm, 0.1%. So, okay, it's okay. I have written here 1 millimeter in 100 mm. That's by mistake. Actually, it's 1000 mm. I made an error. So you can say check for all items. My writing says Fairface does not require any plastering on formed surfaces. Checks for all items should be made for various vertical members as described earlier. Ensure that quality of plywood to be used does not degrade, and also ensure that no more than 3 or 4 uses are made out of new marine plywood, 3 or 4 depending on how many you spoil. Ensure that plywood thickness be 18 mm, not 12 mm, maybe more, but 18 mm, and make sure the pattern of form ply is intact as required. Ensure that ties are provided at design locations, and ensure that plastic conduits are medium to heavy duty, which do not twist. Ensure that plumb does not exceed out of line by 1 mm in 1000 mm. No opening of sides is allowed in fair face forms. No unrequired joints are allowed. Make sure all supports are well anchored. Make proper concreting pouring arrangements. During concreting, no voids or honeycombing are acceptable. This is, you can say, a small definition of vertical members of fair face, because horizontals never come in elevation. So vertical surfaces are questions. In question here, you have to put this fair face, and you can say it's like prefabricated. You precast in yard, and there is no problem of surface finish. You always vertical members are very thin. If you take fascia walls, or if you take, you can say, generally fascia are involved in that case. In elevations, and columns are also involved. Columns, external columns are also involved. But generally, if it is projection all around for purpose of something, it is done. So I'm not separating fair face from ordinary face, because if I produce fair face, it's high standard even then, because it is cast in situ concrete, and you can't guarantee that concrete all time shall be good. Or even if it is good, your people are so responsive that they are so shrewd and awakened to understand and to use timely action. There are lapses, of course, many lapses. In practical work of engineering, you never constantly keep in touch, and fatigue of sight also prohibits people from every time being concentrating. Being concentrated is not possible all the time. But work is work. It's only fair face I'm talking. It's even, I think, simple. If it just your ply is good, your shutters are good, there is no problem. Well, I don't think there's any problem at all. Fair face is wonderful. It can be done if you little concentrate on them. You do good vibrations. You take required slump, and you pour gently in layers and vibrate. No curves should be seen. Means layered concrete and continuous vibration, I don't find any problem. And moreover, fair face is very, every member should be fair face. Why should there be defect? Defects because we are careless. We are not behind work all time. And if we are behind work, we are behind quantity, push. Maybe in beginning we start to prove that we know everything and we do something. But as time passes, as people become used to that kind of environment, and it's for years that project goes on, and they become tired, fatigued. For them, first time, second time it's interest, third time, fourth time it's repetition. So that you can say hunger to learn, which was with them, by passage of time goes dampening, goes into marginalization, and they least bother about, okay, we'll do it, this is routine. And when you think you will do it, I think that's overconfidence. Because every pore poses one problem or another problem. You don't expect same problem in another mix even, forget pore. One batch, second batch, first batch, second batch, third batch, fourth batch. We are going to hundreds of batches every day in pore. Are those same uniformity or they are heterogeneous? I would answer, all are heterogeneous. No homogeneity in that. We have to keep that point in mind while doing something on concrete world. Concrete is friend of none and it is friend with everybody. If concrete is done qualitatively good, it's your concrete. And if it's not done qualitatively good, it's bad concrete. So you want good concrete, that's your concrete, or bad concrete, that's also yours, but it's bad. You can't down to, it's also possible. So that was the only reason I tried to explain fair face. Fair face means real face, means you are spending money, you spend resources, you spend time, you hide reinforcement in this concrete material. And if your concrete material, real concrete material, is reliable, is worth, then you get some kind of pleasure in that also. So my point was different in explaining fair face, and that's the reason I took the time to explain how I consider fair face as well. Now, fair face was one part. We should think every concrete with fair face, though it's not defined. So, again I say fair face does not require any plastering on formed surfaces. But every surface should be formed surface, even though there is no plaster. Sometimes I feel, I suppose I have very good surface finish. I like that surface open, and I don't want to do plaster. Though it's written near the plaster, I suppose I don't want to do. Well, I can't avoid that because it's a question of contact sum or item. Yet if it's done without that, it's wonderful, I can say. So I repeat, fair face does not require any plastering on formed surfaces. Checks for all items should be made for various vertical members as described earlier. Ensure that quality of plywood to be used does not degrade, or it's good quality, you can say. Ensure no more than 3 or 4 uses are made out of pattern of form ply is intact as provided at designated or designed locations. Ties means wall ties or bolts. Design locations means defined locations. Do not keep a tandem. Whatever spacing you decide from one point to another point, that must be followed in all rows and all All such, locations should be in vertical as well as in horizontal row and column. In fairways, in fact, particular holes, you have to fill up them later on, I know, but this should be in proper way. So the filling also looks very beautiful, attractive, and same pattern of rows and column. You can say pattern of form plies intact as required. Ensure that ties are provided at design locations. Ensure plastic conduits are medium to heavy duty, which do not twist. You have to keep in this mind, do not twist. Ensure that plumb does not exceed tolerance. No opening of sides allowed. No unrequired joints are allowed. All supports are well anchored and proper concreting pouring arrangements done. No voids or honeycombing is acceptable. Go to architectural finish works. Surface, or you can say different texture on that surface. Fairface is one part, but different textures we give to surface. What texture? Natural texture. Because we go to do hard work concrete. Hard work concrete. It's hard work. Means it's motif on that, some wall, or you can say we have to know all these points very, very clearly. If we can't understand these points, we can blame ourselves. Architectural finish means a selected texture to be embossed on concrete vertical surfaces. Vertical surface, of course, vertical surface, because in our view, vertical surface is important from all aspects. That vertical surface should be, of course, there should be well control entry, this should be everything. But when doors even open, we have to understand what is we can call architectural concrete. It has different meanings in this architectural concrete, and we have to understand. Well, you cannot form patterns. You can form patterns on you can say ply, but on you can say wood. Planks are wood. These are natural wood, not pressed ply. Ply is not natural, but you can say planks, timber planks, are natural like. They have their own own you can say, imposed on them, can be put on them, so that same texture profile is seen on concrete. Means it's very important part. Of course, we say textures or thickness of planks could be 20 mm or more, and it's of course a strong material. It's a strong material. It's not flexible. Ply is flexible because ply is manufactured in layers. But this is natural product which comes from trees directly, and this is, you can say, not bendable, very little bendable, not bendable in fact, and for purpose of plywood. So you can say checks for all items should be made. Checks for all items should be made for various vertical members as described earlier. Good quality of timber planks of required length, width and thickness are procured. Edges of planks are straight. These are straightened by planer. These are planed, These are made straight for joint formations. There should be no gap between joints of this form. We have to do all work so that these joints remains close to each other, butting, and these joints cannot allow any slurry go out from concrete, and these joints are so perfect without any cavity opening and arranged for a panel of wall and support locations. Arrangement of texture which you are going to do, it should be symmetrical with wall ties which act as internal hold, internal anchorage, and ensure that plastic conduits are medium to heavy duty which do not twist, and also ensure that plumb does not exceed out of line by 1 millimeter, same tolerance limit. Then no opening of sides is allowed in fair face forms. No opening of sides means bulging of surface is not allowed. Unrequired joints are not allowed. No unrequired joints are allowed. Make proper concreting, pouring arrangements, and during concreting, no voids or honeycombing are acceptable. That's very important point. We have to understand that architectural arrangements, architectural, you can say, decoration in structure is not decoration of aesthetic but pattern, permanent pattern of wall, whatever can be given. Try to understand the specific. You may have something like that, or it can be fixed on structure itself, the structural form itself, whatever can be fixed. It doesn't mean fix more than half cover. Suppose cover is 25 mm. You have margin of something. You can tolerate that exactly. So that was point in fair face concrete construction, and now we go to next one, and that is, you can say, Hourts slab works, item 20. I explained before also, but I refresh it. Hourts blocks are trapezium section blocks, trapezoidal section blocks. A wider section of trapezoid remains higher level and lower one remains at lower level. It's hollow Hourts, just like Hourts tunnel it is, and blocks are fixed on horizontal surfaces for purpose of different requirement. Means I want to see my slab bottom straight, felt, and I don't provide any AC there in room, central air conditioning. I don't provide. Maybe I use air conditioning wall mounted or split unit which can be fixed in the wall. We require such blocks in various shapes, various sizes, and we use them for purpose of slab. In this case, slab is continuous all sides. Now we talk of this item which is very much complicated. In fact, we have to decide how to do it because thickness of slab in this is very small, hoodie sizes are considerable, and we have to provide beams through hoodie slabs. Okay, we start our work again here for body precast concrete blocks that we talk of. It's very important item, particularly in ceilings which are free of false work. These are very important for that. I have defined body blocks, trapezoidal one, and plan how it should be done. In slab area should be clear because hollow of blocks are used for purpose of passing services, conduits and others through those, and remaining portion between two blocks is filled with concrete, reinforcement concrete. And then thin slab is connected, is monolithically laid on this system. These body blocks are fixed in both directions depending on requirements, and these act as a structural support to slab. And shuttering is very important. Formwork is very easy. There's no deep drop beam involved in this, so you can say whole level shutters should be checked. There can be no difference in dimensions. It's easy one to understand how they block. Just keep on your shutters fast, very fast, and whatever beam or column you have to side or slab, so continuous difference. We have to get into this position ourselves. So what it says, trapezoidal blocks or hoodie blocks, says check for all items should be made for various vertical members as described earlier. Ensure good quality hoodie blocks, defined dimensions which are procured, and there can be cut size also, there can be ends also. Depending on what's available, you ask for a sheet of that manufacturer who you are going to use. Can be whatever. Ensure cut size blocks to suit site are procured. Then slab form is fixed on scaffolding system as usual. Ensure slab form is fixed on scaffolding system as usual. Ensure whole slab area is in one level without beams form work. Check setting out of beams in both directions, and hoodie blockworks are carried out correctly on lines. Check vertical space available does not mistakenly or non and you can say should hoodie blocks work we carried out correctly on lines. Check vertical space availability for receiving thin slab cast into concrete. Check rebars for beams are placed correctly. Check rebars for slab are placed correctly. Check all services embeds that run through beams as well as through hoodie blocks, wide cavities. Be careful for hoodie slabs works as coordination of services. Works is little cumbersome and complicated activity. Uh, it's to be noted that slab is too thin, say about 60 mm, and therefore services embedments need not find any room through or within slab portion and must be kept within hollow cavities of these blocks, and you have to move in such a way that there is no obstruction to hollow blocks while doing concrete. Then be careful for hoodie slab works as coordination services work is a little cumbersome and complicated activity. That's very important point in hoodie cover blocks. You can see this. You can say that hoodie is a spatial arrangement for flat ceiling. It's very interesting to read this clear catalog data of blocks, and you can pour it there. Now we go on to RCC slope portion floor slab works. We did it before, also we need not explain it. Now we go to compressor foundations. We did last time, I explained to you about compressor foundations, which is very important item. I think I should have worked more on this to show you sketches. I have sketches, and it's interesting one as well. I'll try to find out if I can. I can't guarantee anyhow. I can't guarantee for that, but I'll try to find out. Well, it's not possible, maybe you waste your time. I have actually sketched numbers and not nomenclature of sketch. Had I done that, it would have been better. You can say it would be better in that case. For example, in method statement, say I have this is column, these details are also in AutoCAD. I would like to see these details later. I can column forms, sketches. These XP documents. It won't work, I think. Sketches, documents. Let me see number of sketch. It's bunch building plan, non-building plan, infrastructures, water power, water transmission, building house, it is, then it is concrete test procedures, all that's there, what's that, environmental equipment structures, excavation, grocery, buildings, non-plant, so this can't be that. Just external utilities, building water power generation system, water transmission reservoirs, building house. Let me see what building house says. Let me see what building house says. If something is is not that one. Not that one, no. There's something else I'm showing you. Well, I don't know where is that MS index. Let me see. Every chapter, MS 12, 13 chapter this. Placing concrete service water tank foundation. Compressor structures, RCC column plates inserts. MS2, this I think is good one. Let me see which sketch is good for this. Which sketch is good for this. Reference to sketch 60, 68, 20. 60, 60, 25 is 60, 60, 20. Let me see if I can find that. Management documents 60, 60, 20. Let me please hold on, please. I'm just coming back. That's something I'd like to get good for you if it's possible. $60, $20. Let me see what's 20. It says 60, 60, 20. 60. 60A. 60 is this. What is that? But it's not opening. I don't know the reason behind why it's opening. It's opening. Let me see what it says. 60. I got it. This is something I will show you. It's actually a very important item. My God, why is it not helping me? Well, I think I got something here. I like to show you. I'll just move it, and you can see it is view. And it is rotate. It's gone this way direction, then it's goes goes to this direction. This is something. It is something. It is something. 60A. 60A. This is column inserts. I will also open this. This is I open this as well. And so this is here 60, 20, and I like to open 20A itself. This is C sketch 20. See water pumping. It's okay. I let open this also. It's impossible, not a problem. It's also worth to show. This is sketch 20. So I have many sketches here, to be very frank. Now this is something, a kind of sketch of plant layout. It is. You can see this here. You see this is seawater here. I just like to explain. Let me close this. It's there jetty. You see seawater pumping or seawater basin for something. You put pump here as jetty, and this is, you can see GRE seawater pipeline here, 84 inches. This is double pipeline, and this is drains input compression. Now it says I'm going to define drain first. Means what is this? Let me just blow it up a little. Trains. It depends says that trains include compressors, various equipment, vessels, compressors, boilers. It's also here which says about this pipeline. GRE, this is glass. Now you can see GRE is epoxy based pipes. Glass reinforced epoxy and other pipes. Pipelines run below ground in all process areas. External connections are not indicated on underground utilities drawings. Road crossings are shown on these drawings. Seawater basin supplies water to all trains. Water is used for cooling and water circulation. Some buildings are blast resistant, some buildings are blast resilient, some buildings are non-blast. Processing equipment housed in steel buildings. Now, this is, you can say, refinery plant area here. Let us understand like this. Now, there's a gate, then seawater basin is here. Process area is this one. And this is seawater basin here. You can say seawater basin is here. This very small one. Here is a very small one. This pipes coming from sea, and here are certain process area trains. Train. This is process area. It's written here. Process area in circle, and security storage. Other structures are there. Then there are electrical building here. Substation. It is CCV, Central Control Building. It's a kind of lagoon, open lagoon, and these are offsites here. Electrical building, substations these are. And the other plant here, and here is some kind of non-process area here. You can say it is water compound, or say it's a chiller compound for that, or landscape here, all this one. This is, you can say, administration area. You can see this warehouse storage area, where other buildings are here, and all these are roads. And this is general layout. I say this is C here. You can see this is C. Trapezoidal open ditches on all roads. All road trapezoidal open ditches on all roads. Note shown herein. Storm water, oily water, fire water. Storm water, oily water, fire water. Sewerages are not shown. Process trains details. And you can say this is so big, 3 kilometers, 384. This is from here to here. It's big one. You can't imagine that. For example, this area itself, which is shown in this process one, is 1.5 kilometers here. I am showing you this 3.384 from here to the other point. When you go far away, it's much more. And so this is 1.5. You can say from here to here how much. And this is medical center, fire street, and security, all associated structures are here. But we are talking about compressors here in this process area. There are trains, and in those trains there are some. I will like to show you now what is that I'm talking of. Now what I'm talking is first of all this, you can say, let me see what is compressor I'm talking of. This is, this is what we say, tabletop plan. It is sketch 60, my sketch 60, and this is heavy cracked gas compressor foundation with tabletop sketch 60, all dimension in millimeters. I don't know, bloody fool is calling nonsense, people. They don't understand something is going on. They are just disturbing for nothing. Bloody hell, idiot people, I can say. Hell with you. Get lost. Bloody hell. Least bother about such people. 10. Only doing nothing. Not listening to what I'm talking. Just calling for nothing. So I'm disturbed by these people. If you see these heavy cracked gas compressor foundations, tabletop. This is compressor area, you can say. This is plan. And this is called compressor base. This is compressor here on this, you can say. On this shall be placed your compressor, and these are embeds, inserts. This is base frame, and between this base frame and tabletop, this is called tabletop. This is called complete tabletop. This is top slab, top frame slab. These are columns, thick columns, and this is foundation for compressor tabletop. And foundation plus these columns and this framing, beam framing, is civil foundation for this. This portion of foundation remains in soil. This is 2 meters here written, and it's about 20 or more, depending. I just made 20. Dimension here is different. And if you see here, it is width is 15. Before I told was less, so it is 20 by 15. These 3 rows of columns and 4 here. 4 columns, rows. Size of this column is 1 meter by 1 meter. This is 2.5, this is 2.5, this is 5.5. So 20 by 15, let us say. And here is supporting system, not more than 0.75. It's a grid. Concrete dead load is 5 tons per square meter on this. This is what you say. And here is what you call steel plate inserts. These are voids. These columns which I said, these columns here are these here, and these are in roof or in tabletop. This is block out. This is also block out. This is block out, and this is block out. So you can say this is framing, projection. This is all framing. Massive heavy structure. This is tabletop, and this is direct projection of these blocks. It's a block outs. I think you're understanding. And all concrete members are thick, massive from pouring aspect. So this is a kind of sample I am showing to you about tabletop, so that you should not confuse why I am only talking, not showing to you anything. So now I will go to column, which is steel plate and tanks. Here is a section of column 1 meter by 1 meter, and there are tanks here, there are tanks here, there are tanks here, plate is here, and then tanks here. If you see in elevation, it is like this. This is your plate, this is plate here, whole. This is column, if I say elevation section 9 meters high, 9 meters high column. This is 9 meter plate, and these are tanks here at 0.5 meter spacing, 0.5, 0.5, 0.5, 0.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm sorry, 6 meter height, let us say 6 meter. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 tanks are there in this. And at all 4 ends, it's not one end, 1, 2, 3, 4. So 4 plates in all directions with 12 tanks, so 48 tanks in. So these are all inserts, all inserts for purpose of structural integrity of this column. Inserts in, this is in addition to reinforcement. Reinforcement there. Insert, this is not reinforcement, it's just protective measures. Inserts in all columns of compressor foundations. Steel plate insert. This is that sketch. That's basics of this. Now I'll go further on this. This is as is this. I show to this one. I once again, this is plant. This is plant here. You can see this is plant here, and this is, we are talking of this area. In this area, there are columns. Here are, compressor houses and other structures. Then the other buildings all here in this circle, which is shown process area, and this is consumer residential. Consumer delivered material from here. Then the water, seawater entries from here. You can say hydrojetting workshop is there, but that's something else. I'm not going to. Waste area and warehouses, other plants, buildings, all that, CCBs and control building lagoon and flare tower here in this. This is so much so is there. If we want to show you that in some form. I will show you separately also, but here is this, and you can see this is I showed to you, and this is sketch I showed to you, and so I'm just trying to show you what I wanted to show. I'll keep off these files now because there's no space, so I'll keep off these files. I can select close these files. It unnecessarily takes a space, so I'll try to show you something else also, which I think you got now what I'm saying. You are getting my point in by these sketches, and I wanted to show you something like I forgot what I wanted to show you. Well, it was these sketches in addition to what? In addition to what I said that this process is a high compression foundation works, and so we are seeing make apply to cracked gas and propane, ethane, etc. gas compressors found to be installed within process areas of plants. Dimension formation level is achieved by required fill or otherwise. Formation level is achieved by required fill or otherwise. Ensure that formation level is duly tested and approved. Ensure all precaution required for such area for ingress and egress and other safety measures are adopted. Ensure blinding is well laid and concrete protection applied accordingly. Ensure protection of concrete mechanism, if so required, is applied. Ensure shop fabricated rebars, of course, uncoated are received for installation. Ensure that these cut and bent rebars are rightly tagged. Check about on-site fabrication of forms smoothly going on. For vertical sides, ensure whether or not vacuum test is conducted for concrete protection membrane applied. Should prepared foundation for location of rebar. Ensure that delivered rebars are placed properly using required strong chairs. Consider size rebar, say 25 mm. Ensure that heavy columns or walls, if so designed, are well placed intact into foundation portion. Mind that these bars are always heavy as well. Sometimes bending these rebars is not permitted. It requires ensure that forms are erected and secure. Ensure access to these. Ensure alignment and plumb for forms. Ensure inclined supports are fixed to necessary requirement. Ensure concrete spaces are installed to meet rebar requirement. Ensure certain bars on top are allowed to be fixed later so that entry is allowed to descend to lower bars. Ensure that sacrificial anodes are arranged and their interface connections to foundation rebars are tied up using galvanized wires or cables clamped with S clamps, means C clamps, stainless steel clamps, ensure a sacrificial anodes to be inserted. Don't inserted is duly welded. Inserted welded. Inspection of this has to be done by going to lower reinforcement mesh. Inspection to this anode is done and ensure electrical continuity test is conducted properly on all rebars. Plan for pouring method that has to be approved. Plan for concrete earthing sequence. Plan for pouring working hours. Plan for curing arrangements. Plan for workers deployment. Plan for stepping management of pouring and plan for thermal controls. Plan for working access on top area. Plan for a stand by construction joint forms or stop arrangement to meet an emergency. So we have various provisions. Let me see if I can use something very important, which is much more important, and that is cycle. How to concrete that? If I find, I would try to give you, because it is also very important one from viewpoint of understanding. If I can get it, that I'm not sure. Let me, just like I could find last time, I could find book facilities and stores, and what is that, sketch 177. In sketches I don't find that. It's not available in sketches. I say general facilities framework, Excel 5 advanced, procurement controls, project budget cost, changing cities, housing, office use, facilities, mass block concrete. Mass block concrete, it is that, which is of course interesting one. Let me see if I can open this with open vim. I can say no, in that case it will go worse. So let us say open, and I take printout. I think if it works. If it doesn't work directly, I don't know if it works or not. If it doesn't work directly, I can't say. Let me see, go to this, if I can find this here. No, I don't think it's finding here. I don't think I can find here. No, it's not coming in this. It's not coming in this. It's coming in this, but not in here. I'm not getting that. So let me have, of course, apply for printout of this. Let me try printout and show if you can show. Hold on. Give me some time, please. Hold on. And print. Let me see if I can print this. This is the 8 and okay, it's coming up print. Sort of says mass control block sequence sketch date on it's not wasting time, the mistake. It's not, I put it off, it's not responding. Close program. It's saying that it's open. What does it do? Nonsense. It's hung up now. completely hung up. Oh my God, I'm wasting time with people. I'm wasting time of people for nothing. It's my mistake. I put in myself here. It's not doing anything. It's not doing anything. So let me put it again. Try to open it and do again. Now if I can open it again and do some other way. Let me see if I can print it like this. Come on. It's very small file, but it's not working. Let's see if it can print. I'm trying my best to print it. PDF 8, PDF 7, PDF 8, no, PDF 9, no, PDF 8. Selection, okay, I say okay. Maybe this time I got something, I hope. It's come, good, it's come. So it has come, it's good. You can see that now, I think. You can see that now. I hope you can see that now. It's in there, and yeah, it has come in good, and we can now talk of this. And this one I take off. Take off this. So this is now here, and here you can see this file. Yes, you can see this file. I think you can see this file here. This is an Excel file, and it is showing you complete. I'm just trying to tell you about this statement, which I think is compatible mode. Are you able to see this? I cannot show. You are able to see that. Okay. You are able to see that. Though it's not PDF, but you are able to see that, right? It is compressor foundation concrete pour plan. You can see there are two. One is plan here. If you move like this is a plan here. You can see this is plan here, right? And this is, you can say, you can say this is plan here, and this is what I say. This is PDF, yes. You see, this is, if you take this plan here, 1 meter, 10 strips here, 2, 3, 4, 5, 6, 7, 8, whatever number, 12 or 10. And then I've taken this way 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's maybe 2 meters gap here, 2 meters a strip. Here it is. And this is section of this. It is. You got my point. This is plan which we have to pour. This is plan we have to pour. I'm just trying to show you method of this. This plan, we'll talk in pouring, but just what we do. We have to prepare for this. This total work, concrete truck. Only method I'm trying to tell you. This way, this is a form, this compressor foundation, this is our foundation, is why we do this. In this portion, this is our coverage of shutters. Here are shutters, formwork, and this is our sides. We are going to pour this. You can say file save. It's fine. Now I tried to show you something and I showed to you that one. Now we come back to this proposition again and show this. We'll discuss about this. And here what I was talking of is this. It has to be approved. This is plan for pouring method. I showed. And you can see pouring method is this. Start one. So it is now. I close this. No need of this. And so what we see now is this is your this method and show electrical continuity test we talked of there, and then plan for pouring method that has to be approved, and which is this one, and of course we say plan for curing arrangements, plan for workers development deployment, plan for stepping management of pouring, plan for thermal controls, plan for working access onto top area, plan for standby construction joint form work on stop and arrangement to meet any dam emergency. So this is again you can see it's list of, you can say what we have to see from working and from quality aspect. I am just showing you again and again because this is very important. It's not necessary in talking of compressors. And this can be done for whatever generator foundations, compressor foundations, or else means any whatever heavy machines where you think important method should be evolved. This method which I'm talking about, it was done in 2001, about 21 or 20 years back. It's very old for me. Maybe it's something new for you, but for me it's old, and there may be more development in field, but not more than this. Systems of homework might have come, proprietary systems. We did our own system. We did not depend on any proprietary system, or there may be some other better connections for work, but philosophy remains same. It doesn't change. It says it can apply wherever you want, and it says formation level is achieved as you said by required fill, otherwise formation level is tested, approved. And cut and bend parts are rightly tagged. Then on-site fabrication of forms, if done, is very good. Otherwise, you can get proprietary one, depends on you. That's an expensive one. Then, if it's a proprietary form, should comply with manufacturer's drawings. Check marketing is made on prepared foundation. Marking is made on prepared foundation for steel. That's very easy. Then you can say delivered rebars are placed properly, and you have to provide very heavy standing chairs for work, and then you have to provide all these bars, because these heavy quantity bars are there deeper than human beings. So workers do work safely within the space available. That's also very important. Then fabricated forms are in compliance with dimensions of equality. Ensure the forms are erected in sequence and well supported. Ensure sequential panel edges are well secured. Corner panels are well secured. Well secured because there's no provision of tie rods in this. Be careful. So you have to be very, very smart to connect panels accordingly. They do not move, and also at the corners you have to breakments. There are space, but it is not that one pressure. It's going to be done in layers, so that it's not going to transfer that much pressure. We will talk of when we talk of pouring of this, how to pour, as I showed to you in the sketch of pouring. There's also a specific methods. Ensure sequential panel edges are well secured. Ensure corner panels are well secured. Ensure access to inside of forms being safe. Ensure alignment and plumb for forms. Ensure inclined supports are fixed to necessary requirement. Ensure concrete spaces are installed to meet rebar requirements. Certain bars on top are allowed to fix later, so that entry is allowed to descend to lower bars, and so that sacrificial anodes are erased and their interface connections to foundation rebars tied up using galvanized wires and cables clamped with stainless steel clamps. Ensure that sacrificial anode to be inserted down is duly welded. Inspection of this anode has be done by going to lower reinforcement. Ensure electrical connectivity tests conducted properly on all rebars. Plan for pouring methods approved. Plan for concrete ordering sequence. Pouring working hours. Curing arrangements. And plan all workers deployment. Then stepping management of pouring, thermal controls, working access onto top area. Plan for standby construction joint formwork or stop arrangement to meet any dam emergency. These were very specific points, and let me see how it's working. So scan is going to finish soon, and it's also here 1 hour 42 minutes. Maybe it's good one. I could get you my sketches. That once I have to close this compressor. There's a method statement, this words file, so this cannot help you. I will show you later on. Not now because it won't help. So let's close this file, and I stick to my own file. It's also still there. I can see again. It's still not going. Still it's there. No problem. It's also part of game that we are showing this. It doesn't close actually. So this was that method. Massive block concrete core sketch. I think okay, I'm not discussing that one, but it's there. It doesn't matter. We'll see how to do with that. Now checklist for RCC tabletop columns works now. Columns work. It was foundation I talked up till now. I have showed to you column with tanks and steel plates. So checklist for RCC tabletop columns works. You know what I'm talking now. There's no need of giving any reference. You have seen that column. Now ensure curing for foundation concrete is accomplished. Now of course, when you are doing superstructure work now, though it's part of tabletop, but tabletop not foundation, superstructure. Ensure curing for foundation concrete is accomplished. Ensure construction joint is cabled properly. Where there are 12 columns. Remember, it's 4, 4, 4. In this case, there are 12. So you have to 1 meter by 1 meter size of column. You have to ensure that all latencies is out, all loose particles are out and chipped out or hacked out. so that exposed aggregates are seen. Aggregates are exposed, and that surface is exactly thoroughly roughened for a good construction joint of between old concrete of foundation and new concrete of column. That's what it's a construction joint is scaffolded properly. Ensure column, ensure setting out locations are correct. Of course, you have done it, it's cast, but you have to set out for purpose of placing formwork. Column, so setting has to be checked out and remarked on surface of top surface of foundation, that massive block. You have to make your mark linings, and there's no chance that this steel will be out, steel bars, no way, because we had done all work on that. So you just ensure proper coverage space is available. So ensure setting out locations are correct. Ensure column reinforcement is placed correctly to drawings, because now you have to place again super reinforcement after started columns. Ensure column reinforcement is placed correctly to drawings. Ensure sacrificial anode are fixed to required height. Well anchored. Well anchored. As we discussed, tank plate, tank 12 tanks in one plate, 6 meter high. This ensure tank GI steel plate inserts are available, duly fabricated from workshop. Check proper holes are available for fixing by fastenings to form using bolts. You have to use bolts to fasten more shutters. This is prefabricated plate that you receive from workshop, and you just to fix that on shutters before raising shutters. You cannot. First you have to fix them on shutters on all four sides, and then you fix those shutters after steel is fixed. So this is a kind of anchorage, you can say, that goes into concrete, and it's a system. Means on such thick columns to avoid cracks, to avoid everything. It's a good concrete. You can say reliable concrete. So it's a kind of insert. GI steel plate inserts are available, duly fabricated from workshop. Check proper holes are available. Hole at exact locations where tanks are fixed. And these, you can say, these shutters will be taken out, but these tanks and plate shall remain inside. Check proper holes are available for fixing by fasteners to form using bolts. Ensure all form sides are fixed with inserts properly and inspected. Make sure that tanks of plates these plates should be embedded in concrete. Make sure that tanks of plates should be embedded in concrete. Make sure that all sides of forms are erected. All sides of forms are erected after rebar inspections. Have closure of forms, closed forms, and carry out all column form operations. Check out concrete pouring level. Check form supporting arrangements. Make sure a temporary platform is available for casting. Temporary platform, working platform you can call it, or scaffolding, everything where people can stand in comfortable position and keep vibrators and everything. Good platform, temporary work. And suggested pour in full height if possible. Yes, 6 meter, not big one, it can be poured in one go, but in layers, and you must have that length of vibrator. It's suggested, don't pour in different levels. Whole pour should be cast one time, but in layers. 2 stages of pour can also be allowed depending on column height limits. Even if it is 10 meter, I suggest to do one, but there is no harm. There is no bar you can do in 2 as per introverts. That is what. Then checklist for RCC tabletop works. This is for column, previous was for foundation, compressor foundation it was, and it is for column. Let us repeat for column because this is also very, very important member of this framing. Very important member of framing is so we have to take care of this. We have to understand this very clearly. It's a great point. We have to understand that. Now what says ensure curing for foundation concrete is accomplished. Yes, we have to make sure curing for foundation concrete is accomplished. It's a point we understood. This point you have to understand very well. You have to understand very well. Its understanding is not difficult. It can be understood clearly. It's not that complicated. It's simple engineering. Maybe it's not simple for you because it's a heavy concrete. It's thick element, and thick element has a definition. Just a minute, please. Thick element is a definition that minimum dimension of side of column is 80 centimeters. 80. If it's 80 centimeter and around 8 cubic meter, up to 8 cubic meter, it's called thick element. So it is 1 meter by 1 meter by 8 meters maybe. So it is, say it comes in 80 centimeter dimension. It is thick element, and thick element means it is different world. Mass concrete, massive block, massive column, and that's the reason we are going to provide in that inserts like steel plates with tanks, so that there are two ways. One is vibration transfer, even though we are going to put on top the isolation system. There is already between this machine and column top, and epoxy grouting also we are going to do there, and there's beam frame here. But even then, precautionary measures are required. One is this one, and is the prevention of cracking. So these tanks are there. These tanks have certain function. We have to understand that. These insert salves, there are 12 numbers, you see, tanks and then plate. So it affects something. I can get you more information on, but now I'm just trying to conclude this. I give you that these plates are in. Reinforcement is there, and you can say sacrificial anodes also we fix there. Then tanks plates are already in on shutters, and we put all plates in proper position by drilling holes, and we close all 4 sides. And then before closing, we have to prepare one working platform of good structural, or you can say scaffolding, so people work on that height, don't fall, and we provide access arrangement to that to go to height. Means access arrangement, scaffolding we do, and all we do. We close it and provide supporting system, and that bolting and supporting together. It should be heavy support, heavy bolting, so that column doesn't move out. And we have to then concrete. So we have to make inspections of steel reinforcement, inspection of formwork, which is formwork with this tanked plates, and also then of course general like dimensions at bottom, dimension at mid, and dimension at top, and then 1 meter it is. So plumbing arrangements we have to check, and then supporting arrangements we have to check. So this is what is done. Means after closure we have to do everything. We fix boring levels, then we have to do everything whatever is required. And suggestion is that try to pour in one go, in one stage, rather than resorting to 2 stages. As we do in our country, we just stay in small columns, we can't pour in one go. That is worrisome because we can't maintain quality here. But this is industrial project here. You have to understand what is done and what is to be done. So that's what it says. Then tabletop works we go on. So we have done foundation, we have done columns, all columns we have to do. And now very complicated works come from tabletop works. Tabletop, which is actual beam frame at height that shall receive, that shall allow mounting on this. Mounting on this machine, compressor, heavy compressor, centrifugal compressor that will come on this and sit on this. So this is direct, you can say, base for machine. Column is next one, and foundation is third one. So foundation massive block plus thick columns group plus this tabletop equal to compressor foundation, you can say. So compressor foundation here is massive block of foundation plus group of columns, thick columns plus tabletop, what's massive block. This is also massive block. So beam frame massive block, columns, and then foundation massive block. These three make up your compressor foundation. Did you ever like this? You never heard like this. So this is what learning is all about. Then you say axis of rotation of machine. This is starting one. Axis of rotation of machine. What is axis of rotation? Only manufacturers will tell you, and it should be marked on your plan where does axis of rotation of machine lies and where does axis of your foundation is. Effort should be made to keep them same place. Now ensure grids in both directions are indicated on drawing. Grids on both directions are indicated on drawing. You have to make sure. That's also very important point. You have to make sure that grids on both direction must be. Alright then. Ensure the shop drawings produced and approved. That's essential. You can't run away. You have to. Shop drawing is produced and approved. Check whether or not tabletop is to be produced by one casting. It's important part. It's very important part. You have to see. It's a disputed part actually. Tabletop, check whether or not tabletop is to be produced by one casting, because I met this issue on that project in 2001. I discovered on drawing that there were sections shown and that was to be cast in 3 parts. In that plan which I showed to you, 3 positions were shown. You cast this one first, you cast this one first, and that one. And it was impossible. How to so heavy reinforcement and how can you do this? Means I disputed with them and I wrote to them. I asked them, clarify it. It's a beam design. Your drawing clearly shows pattern of steel clearly shows that this is a beam frame. And if it's a beam frame, means it's a structural frame, and it is engineering interest to cast monolithic. Why are you forcing on this drawing that it should be cast in sections? This is against the spirit of engineering, So what happened? They revised that drawing later on. Nobody agreed with me in the beginning. My colleagues, my seniors, oh no, it's designed, they have done it, they must have thought a lot behind that. Okay, I said, okay, they thought a lot, but let us try. If construction ability is better in this case, what's the problem? If we can cast it one time, why are you so concerned? I said, no, it's not my concern, it's engineering requirement. So query was sent and they said, okay, you can cast in one go. Means sometimes you have to think, that's what I say. Monolithic casting is better or sectional casting is better, you yourself think of. Concrete is better in every case if it is monolithic. If you say you cast one room, column, beams, and so one time, it's better than casting them separate because of various issues. Ensure the shop drawings produced and check which are spec, which not, whether or not tabletop is to be produced by one casting. Certainly beams of top are quite deep and construction joint shall cause practical problems. Have a discussion with responsible authority in this regard. According to engineering requirement, one go for pouring is appreciable. One go, one time pouring. Monolithic pouring is appreciable. Check that column construction joints are well scabbled. That's an important point. Column construction joints are well scabbled. Check columns are rightly marked with datum label. Check formwork is completely erected. Ensure fitness of formwork, preferably by formwork manufacturer expert. This is important. Fitness of formwork, because it's heavy structure and their system on this. Check all access scaffolding is installed for ease of working. Check setting out profiles on forms of slabs. Check all deep beams are correctly marked. Check all blockouts are rightly inspected. Ensure rebars are delivered to be fabricated from workshop or yard. Ensure delivered rebars are placed properly. Keep close watch on works since rebars on such works are complicated in design. Make sure rebar arrangement of placing is rightly followed without causing complications. Check all preparatory works in all respects. Make sure cathodic protection arrangements are rightly installed. Make sure that level of top of concretes are same. It's significant to note that level should be within tolerable limits for space between top of concrete and machine support. Bottom shall be required to be epoxy growth. All temporary and preparatory works require detailed checking horizontally as well as vertically. All locations of defined inserts to be checked accurately. Plan about method of pouring, as pouring requires a good thought out sequence. Have inspection all items involved. This is what is in this. I'll explain this next time because it's already more than 2 hours in this talk plus 1 hour previously, and time is 7:30 around. So we'll take up this swimming pool works and all this later on. So what we have done today is these 3 items. 3 is not complete yet, but I'm just showing we have done today. Refresher of is refresher of architectural finish. We have said RCC fairface structure, RCC fairface structural architectural finish here, and we have said this RCC hood slabs. Then we talked of heavy compressor foundation, and talked of tabletop columns. We talked of RCC tabletop, which we are going to do now later on. Meanwhile, I should be means we can say that talk is not bad today. It's okay. It's fine, and it's fine in a way. It is done. I hope you got something out of this. I tried to show you some representation by sketches, and I have many more sketches. I'll try to bring that onto talk. All are there actually, all are there, but problem is searching them immediately, and I have put numbers only, they are not title of work, and that's my mistake. No problem. I'll unearth them and just put to you later on, because engineering cannot be done without sketches, and sketch immediately tells you what is required. So that's point here. Now I'm going to close this after a few seconds. I understand you got my point of view, and with this, thank you very much, dear friends. Thank you once again. Closing it for now.